Alright, this is Mr. Gillum, and today we're going to continue on with equations, and we're actually going to add one more step, and we're just going to call these multi-step equations. Alright, and so it's kind of a combination of a two-step equation, and we're going to actually add the distributive property today. Okay, so we're just going to add in one more layer of detail. Alright, so the first thing I want to review is how the distributive property works. We've been practicing this property for a while now, but it's always good to review. You'll know to use the distributive property when you're trying to eliminate parentheses and there's no operations that can be performed inside the parentheses. As you can see on both of these examples, 2x plus 1, those are not like terms and I can't combine them together. Same way with the 4x plus 3. And so sometimes those parentheses can be kind of pesky and knowing whether I need them or not. So the one way to get rid of the parentheses is to distribute. And so when we distribute, we take the 3 and we multiply it times everything inside the parentheses. Okay, and once I multiply, I don't need those parentheses anymore. So in this case, 3 times 2x would be 6x. And this is where I seem to see most of the mistakes. Don't forget, you also need to multiply the 3 times the 1. Alright, and that's the distributive property. And as you can see, I no longer have any parentheses. I still have x's and I still have constants, and I can't squish those or combine those together. Okay, so they have to stay separate. Still have two terms. Same way with the 5 here. I need to multiply 5 times 4x and 5 times 3. 5 times 4x is 20x, and 5 times 3 is 15. Alright, and so this is a skill we've been practicing and practicing. In fact, we even went forwards and backwards with the distributive property. We even decided, oh, well, between a 6 and a 3, we know there's a 3 in common, and we know that 2x plus 1 would be 6x plus 3. And so we've distributed backwards as well, and actually we call that factoring. And same way here, if we find the greatest common factor between 20 and 15, we know it would be 5. And so that would leave us the 4x plus 3, which is what we started with. So the distributive property works both ways. Just want to remember that. Someday factoring will actually be more important than distributing. But that'll be for another day. Today, though, we do have two-step equations with the distributive property added on. We're just going to call them multi-step equations. And what we're going to look to do is to distribute where you can distribute, and then you're going to solve a two-step equation using inverse operations, just like what we've been doing the last 2 days. All right, so we're just adding on the distributive property before we begin our two-step process. As you can see, I have the x, the variable, is now covered with more stuff around it. Okay, we're trying to always get that variable isolated or by itself. And so today, specifically, you'll see that there's some distributing to do on these problems. And so before we begin our inverse operations, what we need to do is a little bit of simplifying on this side with the variable. So I'm going to go ahead and start by multiplying the 3 times both parts inside the parentheses. That'll be one way I can eliminate the parentheses, and I can move on to my two-step equation. 6x plus 12 equals 18. Now this type of equation looks a little more familiar. We've been solving these for the last 2 days. So now I'm going to use inverse operations to decide what to do next. And ideally, if I can use adding and subtracting first and then multiplying and dividing second, it'll be able to avoid the fractions for the most part. And so remember that balance is right there, and even though there's more terms on the left-hand side, it is still balanced with 18. We need to figure out how much x is worth for it to stay balanced. And so if I subtract 12 from one side of the balance, I can also subtract 12 from the other side, and I know it'll stay balanced. But I have to also make sure you subtract from both sides. All right. I know that 12 and negative 12 add to 0, or 12 minus 12 is 0, leaving me with just the 6x. On the right-hand side, I have 18 minus 12, which is 6. So now I'm down to a one-step equation, and I see that 6 is being multiplied by the x. There is a multiplication sign in there. They're squished together, but it's held together with multiplication. The inverse of multiply is divide, so I'm going to divide with the fraction bar just like that in that exact. We're not using these anymore. Okay, with a fraction bar, we're going to divide both sides of the equation by 6. Now, part of the reason that we have to use a fraction bar is because if there's more than one term on each side, every term gets divided by 6, and that's a really important thing. And if you're using these signs, you're not going to be able to tell that. Okay, so we do 6 divided by 6, and I know that it reduces to just 1x, or x. On the right-hand side, 6 divided by 6, or 6/6, is the same as 1. So I believe that the answer is 1, and algebraically, this is how I would check. I would say 3, 2, open parentheses, plus 4, equals 18, and I believe the answer is 1, or the solution is 1. So I plug it in, and I would say 3 times, in this case I would do my multiplication first, 2 plus 4 equals 18, and inside my parentheses I'm going to go ahead and keep on simplifying. 3 times 6 equals 18. Because there's no operations inside the parentheses, I don't need them anymore, so I know 3 times 6 is 18, which does equal 18, so I know I did get the correct solution. Okay? So again, I'm probably going to have you check your answers as well, and it's the same process we've been using for the last 2 or 3 weeks now. We're going to take out the variable, put in what we believe the solution to be. Okay? Let's take a look at another one here. And again, what you'll notice is that we have some parentheses and some extra operations we need to do to get that variable all alone. And so in this case, and for today especially, if you see there's some distributing that you can do, that would be a good place to start. So let's distribute the 2 into both parts of the parentheses. 2 times x is 2x, and 2 times 1 is 2. And that is equal to 14. And now you can see that we have a two-step equation, which we've been solving for a while now. We can solve this using inverse operations. If I can add or subtract first to remove some of the things that I don't want, that's the best way to go. So I see this positive 2 here. I'm going to go ahead and add a negative 2 to both sides, or I'm going to subtract 2 from both sides. When I have a positive 2 and I subtract 2, it doesn't leave me with any constants left, so all I have is just the 2x. On the right hand side, I'm left with 12. 14 minus 2 is 12. And again, I want to make sure that we emphasize this is held together with multiplication, and the inverse of multiplication is division. So what I'm going to do is I'm going to divide both sides by 2, and I'll say this again. The reason we use this fraction bar is because sometimes there's more than one term on one side of the equation, and that fraction bar is going to cover everything on one side or the other. If we use this sign, we're going to lose some quotients. So when I divide 2 by 2, I get 1 or 1x in this case. So I know that x equals 12 halves is the same as 6, or 12 divided by 2 is 6. I believe the answer is 6. So again, I could check that solution as well, but it's the same process as before. I'm going to write down the equation exactly the same way with empty parentheses where my variable used to be. Oops, ran out of room there. And I'm going to put in the 6. And so as I'm simplifying, I know that 6 plus 1 is 7. And that's equal to 14 still. And 2 times 7 is 14. So I see that 14 equals 14. I must have the correct solution for the variable to balance the equation. All right. Okay, so I've shown you your 2 examples of how to check your answer with this one. So I'm going to go ahead and just solve this one. And again, I noticed that on one side I have a constant, on the other side I have kind of a complicated term here, a complicated set of terms. And so I want this variable all alone. And today that step that we're adding is the distributive property, and that's going to help us to get rid of these parentheses that we don't want. Okay? Let's take 5 times 2x and 5 times 1. And that's the middle of my balance there. We've got to keep everything balanced, okay? So I got 25, and on the right-hand side I have 10x plus 5, and again I have a nice two-step equation, which we've been solving the last couple days here. Inverse operation says that if I can add and subtract first, that would be the best way to start. So I'm going to subtract 5 from both sides of the equation, because I know that if I have a positive 5 and I take 5 away, it'll be 0. And I'll have no constants left, and I'll just have 10x. And on the left-hand side, 25 minus 5 is 20. And now again, I'm going to emphasize that this 10 and this x are held together with multiplication. Now the inverse of multiply is divide, so I'm going to divide both sides by 10. I'm going to use the fraction bar because just in case there's extra terms when they get more complicated, we need to be in a good habit of using that fraction bar. 20 tenths is the same as 2, or you can think of it as 20 divided by 10. And on the right hand side, I know 10 divided by 10 is 1, or 1x in this case. So 2 equals x, or you may think of it as x equals 2. Okay, that's called the symmetric property when you can switch it around like that. Okay, and then if the instructions say to plug in your answer to show you got the correct answer, you would use substitution to do that, just like I did on the first two problems. But I want to get into a little bit more complicated problem here with you on the video today. And again, we had the same problem here on these that we did before. In this case, we're going to have to use the distributive property before we do anything else. And so I'm going to take 2 times x over 4 and 2 times 3. And in this case, what you're thinking is this. When I'm taking 2 times x over 4, you're thinking really 2 over 1 times x over 4. And so this is why we really emphasize to the cross-reducing, because when I cross-reduce, I see that this is just a 1, and this is just a 2. 2 goes into 2 once and into 4 twice. And so that's a skill that we really have been practicing and practicing that's very important when you're solving equations in our strategy as far as solving them goes. So in this case, what we would have left is just x over 2. Okay, so when I take 2 times x over 4, I'm left with x over 2. And when I take 2 times 3, I equal 6. Alright, and now again I have a two-step equation. Inverse operations say that the best way to go about solving this would be to add or subtract first. In this case I see adding 6, so I'm going to use the inverse, which is subtracting 6. And I know that 6 minus 6 is 0, so I won't have any constants left over here, just x over 2. And that's part of the strategy of getting the variable by itself, is getting rid of all the constants. And so 10 minus 6 is 4. We're getting closer, and now keep in mind that this fraction bar here means division, and the inverse of division is multiplication. So again, one of the things that we stress is that that cross canceling or cross multiplying. Okay, when I multiply these two things, the whole strategy of the inverse operations is to see that, oh, these 2's will cross reduce, and all that I'll be left with is the x. And so that's why cross reducing is such an important skill. So in this case, x equals 8. And again, to check our answer, we would say 2 times in parentheses. We're going to put empty parentheses there where the variable used to be, and it's equal to 10. I'm going to put in that 8 because I believe that the answer would be 8. So 2 times, in this case, we're going to do 8 divided by 4, which is 2. And I'm going to do what's in the parentheses. And I'm going to see that 10 equals 10. So I know I got the correct solution. Okay. And so there's an example of how to check one with the division. Now let's just solve this one and we'll call it a day. In this case, again, I have these parentheses here, and I don't like those parentheses. And one way to remove the parentheses is to use the distributive property. So I'm going to think of it like this. 6 times x over 9. And I'm going to think of that as a 6 over 1. I'm going to look to see if I can reduce or cross-reduce. In this case, I notice that 6 and 9 cross-reduce. 3 goes into 6 2 times and into 9 3 times. And so when I multiply straight across, I have 2/3 with an x on the top. Okay, or 2x over 3. So when I do this first part of my multiplication, I just have 2x over 3, or you could think of this 2x over 3 is the same thing as 2/3, and then the x right off to the side. X is never below, but sometimes people will write it right even with the fraction bar, but we can leave it on the top for now, and that means the same thing. And then 6 times 1, of course, will be plus 6, and that's going to be the one that a lot of people forget to do, the second distributive here. Okay, so now we're using inverse operations, and again, I stressed enough that I think that we know that inverse of addition is subtraction. So I'm left with 2/3 and x on top equals 12 in this case. And then we learned a strategy for one-step equations when there's a fraction in front of our variable. We know that the inverse property of multiplication says that if we multiply both sides by the reciprocal, all the cross reducing will cancel out everything except for the x. So that's one of our strategies. We have cross-canceling to do. On the right-hand side, I have 12 times 3/2, or 12 over 1 times 3 over 2. And so what I'm going to look for is anything I can cross-reduce. And again, I see I can cross-reduce the 12 with the 2. And so all that's left is 6 times 3 in this case, which is 18. So x equals 18. Then you would, of course, need to check your answer and plug that in. But we've been doing that for quite a while now, so I think you can be, or I hope you're pretty comfortable with that. So that's it for today. Today we're adding the distributive property.